Let's dive into the fascinating world of tungsten, a metal that's as intriguing as it is useful. So, buckle up as we explore from its role in lighting our homes to the hypothetical journeys near black holes. First off, tungsten, or wolfram, as it's also known, is symbolized by W on the periodic table. It's not just another element, it's a super metal with some jaw-dropping properties. Imagine a metal so robust that it has the highest melting point of any metal, a whopping 3,414 degrees Celsius. That's hot enough to keep it cool even in the most extreme conditions, which is why it was perfect for the filaments in our old incandescent light bulbs. But tungsten's talents don't end there. It's incredibly dense, almost as heavy as gold, which makes it super tough and resistant to wear and corrosion. This makes it ideal for things like cutting tools and even in military armor-piercing projectiles. Yes, it's that strong. Moving beyond earthly uses, let's get a bit sci-fi, shall we? Imagine a spacecraft built with tungsten, designed to explore the edges of black holes. Its high resistance to extreme temperatures and pressures could hypothetically make it the perfect material for such a daring mission. Or let's stretch our imaginations even further. What if, in a parallel universe, there are life forms based on tungsten? Their existence would challenge everything we know about biology. Back in the real world, though, tungsten continues to play a vital role in modern technology and industry, from being a key component in superalloys used in aerospace to shielding against radiation in medical equipment. Its incredible properties make it indispensable in both everyday and cutting-edge applications. So, next time you switch on a light or see a jet soaring overhead, think about tungsten, a metal that not only lights up our lives, but also holds the potential to unlock some of the universe's greatest mysteries. Now that we've explored the incredible properties and uses of tungsten, you might be wondering, how is this extraordinary metal actually mined? Well, let's delve into the fascinating process of tungsten extraction, which involves two primary methods: underground mining and open pit mining. First, let's talk about underground mining. This method is particularly suitable for high-grade deposits where the tungsten ore is concentrated in narrow veins deep beneath the surface. Miners use specialized tunneling equipment to access these veins. The process involves several steps: drilling into the rock, charging the drill holes with explosives, blasting to break the rock, mucking, which means loading the broken rock into trucks or rail cars, and finally, hauling the ore to the processing plant. It's a meticulous and labor-intensive process, but it's essential for extracting high-quality tungsten ore from deep underground. Next, we have open-pit mining, a method used for lower-grade deposits where the tungsten ore is spread out over a larger area. Large open pits are excavated to access the ore. This involves removing the overlying soil and rock known as overburden to expose the valuable tungsten ore beneath. Once the ore is extracted, it undergoes further processing to separate the tungsten mineral from any impurities. This method is more suitable for large-scale operations and ensures a steady supply of tungsten for various industries. Both underground and open-pit mining play crucial roles in the tungsten supply chain, ensuring that this valuable metal continues to be available for everything from lighting up our homes to enabling cutting-edge technology and scientific exploration. Now that we've explored the incredible properties and uses of tungsten and delved into the fascinating process of its mining, let's uncover some intriguing facts about this extraordinary metal, exceptional hardness and strength. Tungsten is a very hard, dense, silvery white metal that tarnishes in air, forming a protective oxide coating. In powder form, tungsten appears grey. It boasts the highest melting point of all metals, and at temperatures over 1,650 degrees C, it also exhibits the highest tensile strength. This makes it indispensable in applications requiring materials that can withstand extreme conditions. Refractory properties. Tungsten is known as one of the toughest elements found in nature. It is super dense and almost impossible to melt. Pure tungsten, when finely powdered, can be combustible and spontaneously ignite. Its ability to maintain structural integrity at very high temperatures makes it vital in industries ranging from aerospace to electronics. Isotopes. Natural tungsten contains 5 stable isotopes and 21 other unstable isotopes. These isotopes contribute to its various properties and applications. For instance, its isotopic composition is crucial in scientific research and medical applications, providing insights into processes ranging from geological dating to cancer treatment. Historical origins. Tungsten was first isolated in 1783 by Spanish chemists Juan José and Fausto Eluyar. It was obtained through charcoal reduction of tungsten oxide, WO3, derived from the mineral wolframite. The names tungsten and wolfram have been used interchangeably since its discovery, with tungsten referring to its Swedish roots meaning heavy stone and wolfram originating from its German mining history. From its exceptional hardness and strength to its rich historical origins, tungsten is truly a metal that masters extremes. Now that we've uncovered some fascinating facts about tungsten, let's delve into some intriguing historical anecdotes related to this extraordinary metal. The strategic metal in World War I, tungsten, often referred to as the armor plate of conflict, played a pivotal role during World War I. Its remarkable properties, extreme hardness, high melting point, and resistance to stress and heat, made it invaluable for military applications. Germany was a world leader in producing tungsten steel, using it to build more durable weapons, especially artillery. England, however, had a mine in Cumbria, Carrock Mine, that produced high-quality tungsten ore. Unfortunately, it was owned by Germans. The German-owned Cumbrian Mining Company took over Carrock Mine in 1904, fully aware of tungsten's potential. Tungsten steel was used for armor plate, cutting tools, and other critical components. Remarkably, much of the tungsten mined in England up to 1912 ended up on the battlefields of the Somme. The discovery and isolation. Tungsten was first isolated by Swedish chemist Carl Wilhelm Scheele and Spanish chemists José and Fausto Eluyar in the late 18th century. Its discovery involved intricate chemical processes and laid the foundation for its industrial applications. The Eluyar brothers isolated tungsten by reducing tungsten trioxide with charcoal, a groundbreaking achievement at the time. Civilization without practical use. Despite its strength, most of civilization lived without any practical use of tungsten until recent times. Only in the modern era have we harnessed its incredible properties for various industrial and technological purposes. Its applications range from the filaments in incandescent light bulbs to critical components in aerospace engineering. From its strategic importance in wartime to its groundbreaking discovery, tungsten has a rich and varied history. Now that we've journeyed through tungsten's rich history and its role in conflicts, let's dive into the world of tungsten alloys, remarkable materials that harness tungsten's unique properties to create supermaterials for modern applications. Tungsten, nickel-iron alloys. These alloys contain 97% tungsten, combined with nickel and iron. They offer exceptional strength, ductility, and density, making them ideal for balance weights, radiation shielding, and defense components. Imagine the precision required in aerospace or medical fields. Tungsten nickel-iron alloys provide the reliability needed. Tungsten copper alloys. Combining tungsten with copper results in a material with excellent electrical and thermal conductivity. These alloys are crucial in electrical contacts, heat sinks, and high-performance electronics. Next time you use your smartphone or computer, remember that tungsten copper alloys help keep them running efficiently. Lanthanated tungsten alloys. Adding lanthanum to tungsten improves its electron emission properties. These alloys are commonly used in cathodes for electron microscopes and X-ray tubes, playing a vital role in scientific research and medical diagnostics. Tungsten chromium alloys, enhancing wear resistance and high-temperature stability. Tungsten chromium alloys are used in cutting tools and aerospace components. The next generation of aircraft and spacecraft rely on these materials to withstand extreme conditions and perform flawlessly. Tungsten rhenium alloys. By combining tungsten with rhenium, these alloys achieve improved high-temperature strength. They are essential in aerospace engineering, particularly in rocket nozzles that need to endure the intense heat and stress of space travel. Tungsten carbide, not an alloy but a compound, WC. Tungsten carbide is extremely hard and wear-resistant. It is widely used in cutting tools, drills, and industrial machinery. From mining operations to precision machining, tungsten carbide is indispensable.